We are working still on solving equations. This is not inequalities now. We're solving systems of equations. Okay, we are looking specifically at linear equations, which means we just have y equals mx plus b, or we have it in general form. So a system of equations is when we have two equations like that. They are both equations. One is in slope-intercept form. One is in the standard form. We could graph those. We could see the point that they cross. That would be our solution, right? So the solution that we're looking for is the point of intersection. And Braille, what do we know if it is a solution? If I put it in both equations, what happens? If I put the points that I find in both equations, what happens? And are the answers true or false? Do they work or not?
Well, wait,
If they're, well, yeah, we don't know. If we find the point of intersection, will it work in both? Yes, it will work in both. So our solution is the point that makes both equations true. That's what a point of intersection is, because the line is actually representing all the points that make that equation true. And so if we have two lines that represent the two different sets of points, the ones where they intersect will make both of them true. Okay? So when we are doing this, we can graph, we can find the point of intersection, and at that point we'll make both of them true. But sometimes our equations are such they're not easy to graph. Or we get points that are not exactly on an intersection. Like we don't get whole number points. Okay? Getting non-whole number points off of a graph is very hard to read. We don't know exactly what they are. So we're going to look in, because graphing really works, is best if the points are integers. Not always do we get integers. Sometimes we get a third, or they intersect at 2 and 8. Or they intersect at 5 and 7/8 and 3 and 2/3. We get fractional answers. Okay? So if they don't intersect right at integers, right at those crosses on our graph paper, it's not easy for us to determine exactly what point do they intersect at. Okay? So that's why we use another method. So this is a method called substitution. So we use a different method. And 10.3 or 10.2 and 10.3 are about the method called substitution. Okay. So we are looking at, is it not upright?
It's not.
Is it not locked?
It's not locked.
Okay, get it locked.
Yeah,
Don't
I
want
kept
falling
tilting
on
your
you.
way.
Oh,
Okay.
hold on, this one might not be locked either.
Lock them.
It was locked.
There we go.
Okay, so what we're looking at in these two sections is we're looking at a different method to solve equations when we don't get integer numbers as answers. Now, does that mean every time I do one of these problems, I won't get an integer? No, that's not gonna be true either, okay? They're gonna give you some that are integer ones also. They're just showing you that it also works with these, okay? Now, knowing me, when I put stuff up there like this, they won't be integer answers, because I just made those up out of my head right now. And so most likely, it would be a miracle if those two had integer answers for those system of equations. I'm just saying that these probably do not, because I didn't look at any book to see what they were. I didn't even think about it when I wrote it. I just wrote two equations up there. So most likely where they cross is not at a nice number like 2, 0, or 1, -1. It's going to be probably at some sort of fractional points. Okay, so let's look at how we do this. So I'm going to leave those two. We're going to now look at what is substitution. Okay. If you have a substitute teacher, what does that mean?
You're taking the place temporarily taking the place of the original.
Yep, you're temporarily taking the place of the original. Somebody comes in here and replaces me. Okay, they're equivalent to me usually in some manner. Hopefully they know math, so they're equivalent to me and that they can teach you math. Okay, so substituting here is I'm going to take something that equals one of the variables and substitute it into the second equation. So you find something that equals one of the variables. I could call that, if you want to be, instead of something, we could say an expression that equals one of the variables. And then we're going to substitute that into the other equation. So if I look at this set, and I did this on purpose, notice that I have y being the same as 3x minus 3. Do you see that? Y is the same. It says y equals 3x minus 3. So they're interchangeable. Y and 3x minus 3 are the same thing. Okay? Because if they're equal to each other, that means they're interchangeable. So what I'm going to do is I'm going to take this, and where the y is down here, I'm going to put the 3x minus 3. We're going to substitute in that expression for y into my second equation. So what I'm going to get is 2x plus 4, and where y is, I'm putting 3x minus 3. So notice all I did was replace y with the 3x minus 3, and that's going to equal 7. Is that what I had? Yes. So I took the first equation here and plugged the equivalent expression in. So we have to use two different equations. Don't try to put it back in the same one, because then you're just going to get zeroed out because they're the same line. Okay. Now I can solve this. We know how to solve these problems. What do we have to do first, Med?
Put 4 times -3 to 4 times 3.
Yes. Okay, so we're going to take 2x plus 4 times 3x, which is 12x, 4 times -3, which is -12, equaling 7. Okay, so we did our distributive property. We distributed it out. What should I do next, Mason?
-12 minus. Well, you would actually have to add 12.
That's correct. We have to add 12 on both sides. Okay, because we want to get rid of the 12 there. So I've got 2x plus 12x equals 19. Told you they weren't going to equal nice numbers. Okay. Max, what am I going to do next?
Next, you would need to get rid of one of the x's.
Could I get rid of both? Could I
Oh.
put them together?
Yeah, you could.
What would I get?
You would get 14.
14x. 2x and 12x's are 14x's. That equals 19. 14 divide by 14.
1.35714.
And why do I not want to divide it?
Because it gets that, what I just said.
Gets an approximate number, so we want to leave it as 19 14. Did I do something wrong, Grayson?
No,
Yes. Do you have a question?
no, I was just gonna say it would just be easier, or it would be more exact to leave it as a
Yes,
fraction.
correct. It's more exact as a fraction, so we don't want to put in decimals because then we are rounding. And when we put them back in our equation to check, they won't be exact numbers if we round. Okay. I don't care.
Whoa.
Now, I have x. Am I done?
No.
Am I done?
No, we're trying to find y.
Why? I have to find y. Why do I have to find y?
Because you only have 1 point. You can't have a line without 2 points.
I have to have a point which has two different numbers in it, both the x point or the x value and the y value. So now, how do you think I'm going to find what y is equal to? Yes.
Do we like put 2x plus 4y, 4 like into y, like have it be 2x plus 4y equals 3x minus 3.
What if we just find the, wait, 3x minus 3 is just already y.
Oh, it is. Look at this equation.
It's already y.
Y is going to be
Just copy each other.
3x minus 3. Do we know what x is?
Oh, we solved for x. That's
Do
not
we
too
know what x is? We can substitute that value for x back in. So now we get y equals 3 times 19/14 minus 3. I didn't say this math was going to be easy. I just said it was going to. This is a good review of fractions. So, y is going to equal, what do I do first? What am I going to do first? Grayson.
Oh, you multiply 3 and 1914.
Okay, how do I do that?
You could just make it 3 times 19 over 14.
Okay, so we can make that a 1. 3 times 19, which is 57, is that right?
Yeah.
57/14 minus 3. Okay, so our first step was to do that multiplication. Multiplication, we're just going to multiply the 3 times the 19 because it's really 3 over 1 times 19 over 14. Okay. Now, how do I do a subtraction of 3? How do I get the answer? Grayson,
Get a common denominator.
get a common denominator. What's our common denominator going to be?
Probably 14.
Probably. Okay, so y is equal to 57 over 14 minus something over 14. Okay? So we want the denominator to be the same because we cannot add or subtract fractions unless our denominator is the same. So what would be the numerator on that, Med?
Negative 42. Wait.
Just 42 right now because I have the minus sign.
Oh, okay.
So 3 times 14 is 42 because I multiplied this by 14 and this by
It's the same
14. Why can I multiply by 14 over 14? Yeah,
Because that's the same as 1.
it's the same as 1, and if I multiply by the same anything by 1, I still get the same number. So this is the same number because 14 over 14 is just 1. I'm multiplying by 1, so this number is the same as that. Okay? So now we do our subtraction. So what do we get? Ava, what's our answer going to be?
8.
Try again. 57 minus 42.
Oh, it's been a while. Oh, wait. Why is this so difficult?
That's okay. I'll let somebody help you.
I know.
Mason,
15?
it's 15.
Do you know?
I don't know.
Oh, that's.
No, I knew obviously.
What is the denominator going to be? Mason?
14.
Okay, it stays the same.
I knew that was, I knew.
Who taught you?
What is my point where they intersect? What is the point where they intersect? Brielle, what's the point? Point has 2 values. So what's the point?
Wait.
What 2 values does it have in a point? What's the first one? X. Then
Y.
so what is my X
Which one?
for right now? What's my X?
Oh, 19.
19 over 14. What's my Y? Mason?
15 over 14.
15 over 14. Though that is the point of intersection. We just went through it. Now, you can check that by going back and putting it in here. Okay? You could go into both equations and you should get the correct answer. You can use your calculators to do that, to check them. But I do recommend that you check them because that way you know you've done the math correctly. If it works in both of them, you know you don't even have to wait for me to grade it. You know you've got the right point. Okay, so you can grade your own work by checking it. Okay? So that's the idea of substitution. If I would have graphed those, I wouldn't have seen 15 14s. It would have looked like a little more than 1, but I wouldn't have known how much exactly more than 1. This would have looked about 1 and maybe a third
1/14.
or so. It would be 5 14s, okay, which is about almost 1/3. Okay, so this would have looked like 1 and 1/3, but that would have been really hard to get the exact numbers. And in real life, a lot of times they're not exact numbers. Okay. A lot of times we're dealing with money though, and we would use decimals, but we would round. Okay, when we use this in actual, it's a break-even point a lot of times. Businesses use this type of idea to solve break-even points. They're talking about money and number of quantities of things. And so then it would be a number that you round. You wouldn't have to leave it as a fraction because you would round it to cents. You're not going to 2.7654327 dollars is not something we normally say. Okay, so that's where we don't go that way. So that's all what 10.2 is about. It's about substituting numbers in. Okay. We are going to take a break, and when we come back, we're going to look at 10.3, and you're going to do some things up on the board today.
Jason, how do you know?
What do you mean?
How did you know she was gonna